Hi guys, today I'm going to solve the problem, the second order ODE with constant coefficients. The question is like 4y dot dot plus 3y equal to 0. To solve this kind of second order ODE, we can assume the solution like y equal to a exponential lambda x, right? So what about y prime? Y prime means that derivative for x. So lambda a exponential lambda x, right? And what about y double prime, which is lambda squared a exponential lambda x, right? And then we can substitute this kind of value to original equation. So for what about y double prime equal to lambda square a exponential lambda x and plus 3 a exponential lambda x equal to 0, right? So we can rewrite a exponential lambda x equal to 4 lambda squared plus 3 equal to 0, right? So from here, this guy equal to 0, right? So 4 lambda squared plus 3 equal to 0, right? So lambda equal to plus minus I, right? Scale root 3 over 2. Now, there are two types of the answer for lambda. The first one is y1 equal to a1 exponential lambda 1x, right? So a1 equal a1 exponential plus I scale root 3 over 2x, right? We can rewrite this one by using Euler's equation. So a1 cosine 2x plus I sine square root 3 over 2x, right? Euler's equation. What about y2? a2 exponential lambda 2x, right? So a2 exponential minus I square root 3 over 2x. And we can also use, by using Euler's equation, we can rewrite this equation such as cosine square root 3 over 2x minus I sine square root 3 over 2x, right? So we can find the answer like y1 plus y2, right? Why? Because the system is like a linear, so we can use superposition theory, right? Principle. By using superposition principle, we can find another answer, y1 plus y2, right? So a1 plus a2 cosine 3 2x plus a1 minus a2i sine square root 3 2x. If we can call this term large A and this term large B, we can rewrite y a sine square root 3 over 2x and plus b cosine equal to 3, 2, x. Right? This is our final solution. Very straightforward, right? Okay, thank you.